Okay, so this is help on chapter 4, number 11, 13, 16. So this is all about forces. So let's look at number 11 first. So 11, I'm going to write the givens down, but when I write the givens, I'm also going to draw the model over here, and that's going to count as some of my givens. So I'm going to know that my forces are given. So in this question, we have a boat. So the force of the boat is here, and uh, the force of the water is here. And I'm asked for what is the acceleration. So I'm just going to use my formula. Sum of the forces is equal to mass times acceleration. But when I sum the forces, I need to add both of these, but note that the FW is going left, so it's negative. And then I'm just going to solve for my A using this. So know it, know it, know it. I can solve for it. Okay, part B. Now I'm given extra givens, but I know my A because I solved for it here. So I know A. I know V sub 0 is 0 because it's from rest. They give me time and they ask for delta x. So I have to use my kinematic equations. So if I use my kinematic equations, I can use this formula, and I know it, know it, know it, so I can solve for it. And the last one, C, it just asks for now what's the velocity? Well, I can pick another kinematic equation and solve for final velocity using these variables. Okay, 11 is pretty straightforward. And again, I hope you guys realize that you need to be trying these problems before you get assistance on the video. So that's really the way that you're going to learn. Okay, so number 13, again, it's pretty straightforward. And actually in this one, they give you a lot of extra extraneous information, which makes it a little bit confusing. But you just have to focus on what they're asking for. So again, in this case, it's a car. And it gives you, it asks for what's the average force. So the average force would mean the sum of the forces. And if you think about a car, it would have the force of the engine, and it would also have the force of the friction of the road. But we're not going to draw this because it's just a pretty straightforward calculation. If I'm looking for force, well, I need to know the mass and I need to know the acceleration, and those are both given. So I just use this equation right here. And I didn't need to know the velocity, or I think they give you time in there too. So you don't need to know velocity or time. So these things are extraneous information. Okay, so let's look at number 16 now. Alright, so number 16, this is a trickier problem. So 16, now they have a sailboat. So we have a sailboat, and it's got the force of the sails going north, but the water force is going east. So I got force of the water is east, and the force of the sail is north. So they also give me the mass and they ask for the acceleration. So again, I'm going to use the formula sum of the forces is equal to mass times acceleration. But now I'm summing, like this is where my vector work needs to come in. And so in order to sum the forces, well, I need to, since they're perpendicular, I need to add these doing tip to tail. So I'm adding my vectors. So notice I can just move my vector, the FW here, and then I'm going to move the FS so that it's tip to tail. And since they're perpendicular, since this is perpendicular right here, then to find out what FR is, so to find out what this FR is, I just use the straightforward Pythagorean theorem. So a squared is equal to b squared plus c squared, but since I'm finding what this is, I take the root of that. Okay, so that gives me my summation of my forces. So I'm just going to use Fr is equal to mass times acceleration, and then I can solve for this. I can solve for my acceleration. Okay, but they also ask for direction. So the direction of A, well, you got to know the direction is in the same direction as the resultant force, because force is mass times acceleration. Mass is a scalar, so the acceleration is the vector. So the acceleration and the force are in the same direction. So I'm trying to solve for this angle right here, and this angle, I would use the tangent. So tangent is opposite over adjacent, so my opposite over my adjacent, and I solve for what the angle is, and I should be specific here and say, since this is the angle that I'm finding, that this is the angle is north, or I could just put from, well, I'm going to be specific here and say that it's north of east, which means that it's from the positive x-axis. So I'm saying that it's north of this east axis. You could have solved for this angle right here, which would have been okay as well, but then you would have to say that it's east of north. So then that would switch things around. So if you did that, that's fine. That would give you a different angle, but when you specify that it's east of north, that tells you that it's from the vertical axis. Okay, I hope this helps. I didn't do any of the substituting in of the values, so I'll leave that to you to do.